My dear students, class 9. On request, we have taken a topic for presentation, a topic that we have taken uniform accelerated motion equations. So there are three equations for an object in uniform accelerated motion. So equation number 1, that is v is equal to u plus at, and equation number 2, that is s, the displacement s is equal to ut plus half at square, and here you see equation number 3, v square minus q square is equal to 2as. So these are three equations of motion. So let's explain, means let's derive algebraically, okay, and it can be derived or explained graphically, okay. So let's derive algebraically. Okay. Now see, so object here, the object is at A and moves to B in an accelerated motion. Okay, so uniform accelerated motion. So the means the terminology that we have used, the symbols, signs that we have used, that is V for final velocity, U for initial velocity, A for acceleration, T for unit time in second, that is S for displacement. So these are the symbols that we have used and that have been used in all three equations. Now you see the initial velocity at A. So when the object is at point A, the initial velocity is u, and after t seconds, after time t, and it reaches point B, and the final velocity is v. Then we know what is the change of velocity. So that is v minus u. It is very simple, and that change in time t. But as per our definition, we know acceleration is the rate of change of velocity per unit time. Rate of change of velocity, rate of means per unit time. So rate of change of velocity. So change of velocity, that is v minus u, that we got here. For unit time per second, that is v by t to a. Now we got the equation. That implies a is equal to v minus u by t. And by transposition, at is equal to v minus u. And v is equal to u plus at by transposition. Now we got this equation. Equation number 1, v, the final velocity, is equal to initial velocity plus the products of time and acceleration. So from that equation, we can also derive at is equal to v minus u by transposition, and t is equal to v minus u by a, and we shall use this formula in deriving our second equation. Okay. Now you see, come to the second equation, that is s is equal to, so what is s? S is the displacement. You know, that is the velocity in time, the displacement or the distance covered here, that is speed into time or velocity into time. And here you see this velocity, and it is called the average velocity, VAV we have taken here, average velocity. Here velocity point A and point B are two different velocities. So the object moves with an average velocity u plus v by 2, that is average velocity. Okay. So average velocity into time t, that is into time t. Now you see, so we can actually apply this formula v. V is equal to u plus at, that we have derived here. So v is equal to u plus at, that we have derived in the equation number 1. So put this, so substituting v, you can write u plus at plus u by 2 into t. Now u plus u is equal to 2u into t, 2ut, and t is multiplied at square, t at into t at square by 2. Okay, and the denominator actually this term, this is an expression having the denominator 2. So we can write 2ut by 2 plus 8 square by 2. So now 2 cancel and ut. So we can write a half 80 square. Now we got the second equation. So yes, the displacement is equal to ut plus half 80 square. Okay, now we got it. Now you see the third equation, that is v square minus u square equal to as. Let's derive. The same formula you please apply. The displacement is equal to the velocity of time. Okay. So here velocity, the average velocity VAV, that is v plus u by 2. Now we put here v, that is v plus u by 2 into t. So I told you actually here we have derived t. The time t from the equation number 1, time t has been already derived. Okay, let us put. So means in place of 2, substitute the value of t, that is v minus e by a. V minus u by a, right? Okay. Now there are two factors. Then the product of two factors is equal to, that is a plus b, a minus b. That identity you know, that is v square minus u square by 2 into a, 2 into a. Okay. So this is LHS and this is RHS. So by transposition, by changing the side, so we got 2as is equal to b square minus u square. Okay. So b square minus u square 2as. Now we got three equations of motion. Number 1, v is equal to u plus 80. Second, the displacement s is equal to ut plus half 80 square. And third, the v square minus u square is equal to twice as. Okay, and the symbol that we have used, let me explain once again. V for final velocity, u for initial velocity, a for acceleration, t for unit time, and s for displacement. Okay, thank you. Hope you have understood the algebraic derivation that has been explained in your textbook. And in our next class, some students they have actually act to derive all these equations graphically. Okay, so we shall present the graphical representation of equations of motion. Thank you all for watching. Stay tuned to watch our next video on this topic, that is graphical representation of uniform accelerated motion. Okay, thank you all for watching. Thank you all for